what is exactly a Teradata, right? So what is special about Teradata? So let me just give you a quick introduction about that. So, so basically, Teradata is nothing but another relational database management system. Okay, so let's say RDBMS. I think you have already heard about RDBMS. What is an RDBMS? It's nothing but a relational database management system, and Teradata also comes under the same category, right? Then why so special about Teradata? Okay, so in today's world, you you might have heard about data warehousing, right? Everything about data. So in the today's corporate world, every decision can be taken by analyzing the data requirements. So, for example, I'm a CEO of a retail company like a Walmart. That's an example. So I have the inventory already in my place. So for example, if some product is getting outdated or the inventory it is not there, so I have to order a new bunch of stock. So I have to go for the new order, right? So before going for, I have to do some kind of analysis like how is the trend about the product. So what about the new product being launched in the next month? So to give you an example, for example, let's say product ID, product name, percentage of sales, average profit, and revenue generation, revenue amount, something like the product 1, 2, 3, 4. Let's say Nikon cameras and percentage of sale 45 for the last year, and average profit is something like this in dollars. Revenue was something like this. So basically, what we are actually trying to do is trying to get some kind of aggregation information into the data warehouse to see kind of years like 5 years history, 10 years history for a product to understand the nature of the business. So that what we can do is we can analyze the business trends and how exactly we can see the profit, the growth of the product. Before I wanted to order a new inventory for Nikon cameras. So currently I see the trend is falling down. Let's say example, in the recent years what happened was there was a dramatically decrease in, the drastically decrease in the revenue of Nikon cameras. So obviously we have to go for other products, right? So obviously we have to check why what happening there, like what is the reason for lowering the sales, right? Before that we have to take some kind of analysis and then go for a decision whether to order a new inventory of Nikon cameras or we can go for a new model, right? Something like this. So this is basically a concept called data warehousing, right? That we all know. What is a data warehouse? Basically, data warehouse is nothing but a, a storage of data wherein we can actually, just based on the data, we can take the strategic decisions for a business. So like subject oriented, integrated, non-volatile data which will be used in decision making process. So these are the characteristics of data warehouse data. So what is subject oriented? Basically in the data warehouse we have, for example, take a sector, retail market, we have different sectors like marketing, finance, administration. So we can store different subject areas into a single place called a data warehouse in the form of data marts. Data marts is nothing but a subset of data warehouse, right? So subject oriented in the sense we can actually store the data based on some specific information or specific group as such. Okay, and integration is nothing but we can actually integrate the data from different sources into a single source of truth. For example, the data coming from different front-end systems, and finally we are storing the data at a final data warehouse layer. That is called integration. And non-volatile is nothing but once the data is loaded into the data warehouse, we don't delete the data in data warehouse because it is a pure analytical data. So we don't need to delete the data quite often, right? And data warehouse sizes will be very huge because they're supposed to carry huge data because we are doing the analysis on it, right? So once the data is loaded into the data warehouse systems, the further reporting tools will help us to do some kind of analysis basically. So as an ETL developer or a Teradata developer, our responsibility is to load the data into the data warehouse. So from different systems or from different databases, we can load directly into the Teradata final database that is called data warehouse. So that is the overall background about data warehouse, right? So any idea, I mean any questions here before we get started for other concepts?
So is Teradata just for data warehousing thing, not for OLTP?
So it's not only OLTP. I mean OLTP is typically a transaction processing wherein we see on a day-to-day basis in a banking or you see, right? That is OLTP. OLTP is very dynamic in nature and very up-to-date information is available. Whereas data warehouse comes to OLAP structure. So there are two type of systems, right? OLTP and OLAP.
Right.
So
My
on
question
a
is, no,
yeah.
my question is, Teradata supports both OLTP and OLAP, or is it just only for OLAP processing?
So I mean depends on the requirement. It supports both OLTP and OLAP.
Okay, so does it have any special feature just for supporting the OLAP, Because
Yes.
basically when I read something online, it says Teradata is mainly for OLAP concepts and not for OLTP. So I don't know if I
Yes.
might be wrong, but you can.
Yeah, I'll come to that point. So basically, Teradata uses as a data warehouse in most of the projects. So that's why people know it's an OLAP system. So why? Because in because in RDBMS, any RDBMS can be act as OLTP as well, right? So what is the issue here is in OLTP, the inserts and updates should be faster, but Teradata, the inserts and updates are much slower compared to other databases. It has the high capability of selecting the data from a repository. So the select will be much faster in Teradata compared to other databases. It can fetch billions of records within less time. So the OLAP is basically what is meant by OLAP, nothing but analytical processing data, which can have multiple dimensional data loaded into the fact table with the normalization will be in second normal form. That is the data warehouse data wherein we don't have the unique IDs, like we can have number of records, duplicate records in the data warehouse because we can maintain the historical data as well, right? Along with the history information, we do some aggregation kind of stuff which will be used for analytical data. So when you use a select query in the OLAP model, so obviously the joins will be used and will have a lot of time required to get the data. But Teradata helps you to make your job easier when you use its OLAP systems.
Okay,
Okay.
okay, yeah, correct.
Okay, so that is about a overall picture about data warehouse. And coming to Teradata, why only Teradata? So Teradata started in early 1980s. They developed the corporation, and finally it's merged into NTT. It is NCR Teradata Corporation. So later they have divided again into Teradata separated. So that's the historical background about Teradata. So, and we have other databases in market like Oracle SQL Server, Netezza, DB2, a lot of what do you say, DBMS, RDBMS in the the today's world. But why is Teradata is little special place in the market because it has a special feature of operating in parallel processing. Okay, the first thing is parallel processing. We'll talk about in detail like what is a parallel processing concept before going there. So Teradata is known for parallel processing and high efficiency in terms of reporting, especially select queries with complex joins. Okay, and maintenance is easy for DBS especially. Okay. not much configuration for DBS is required. Configuration or day-to-day activities, and these are the pros basically. I mean, okay. So parallel processing and high efficiency in reporting, and maintenance is easy. Not much overload or burden is required because Teradata is easily maintained. So these are the concepts in Teradata that is actually taking Teradata to the next level compared to other RDBMS. Okay. So what is parallel processing? We'll talk about architecture in detail. So parallel processing is nothing but whenever you write a query, Teradata actually uh, puts the data in different AMPs. I mean, we'll talk about the components now. So what is Teradata architecture? We have a set of components here like parsing engine, binet and AMP and disk storage. Okay. So what is a parsing engine? Basically, parsing engine is nothing but which will actually take the request, all the data processing things, and it will check for the syntax of the query, and it will see the optimized plan for your query, and all the stuff it will be done at parsing engine. So once the parsing engine decides what query you have to write, right? What is the best query that you are using the joins and all, and then it will talk to the AMP by using the binet. Binet is nothing but a simple communication mechanism in Teradata, which is a cable, optical fiber cable. So the binet can be used and after parsing engine as a communication mechanism to the AMP. AMP is nothing but access module processing unit, which is a very key component of Teradata systems because it is, I said, it is a parallel processing database, right? So what is parallel processing here? So basically, whenever you send a request to the parsing engine, I mean, you write a query in the database, so the parsing engine will decide and tell the AMP that you have to distribute the data accordingly. So for example, parsing engine writes some query, and after all this session control parsing the query, optimizing the plan and dispatch the request to the binet, the AMPs will actually distribute the data among themselves. I mean, there is no shared concept here, that is called shared nothing architecture, because each AMP will work separately on their data, because the data will be distributed evenly across all the AMPs based on your primary index and all the stuff. So whenever you retrieve the data, for example, you're writing a query called select star from table name. So all the data can be pulling from all the table, the corresponding underlying table from all the AMPs, not only single AMP. For example, there are let's say 20 rows in the table, and there are 4 AMPs. All the 4 AMPs will act in parallel, and 5 rows from AMP. Each AMP will be pulled in and get back to the binet and to the parsing engine back. That is what the parallel processing concept here. So it is mainly the data distribution and the data retrieval is the special thing in Teradata. Okay. So all the data, yeah.
I have a question. What do you mean by AMP? What exactly is the AMP?
Yeah, so AMP is an access module processing unit. Okay, so for example, it's like a vproc in the Teradata, virtual virtual processing unit, right? Or you can say in Teradata software, AMP is basically a kind of a temporary memory wherein you can find all the operations on the data. For example, you write some aggregation, maximum of students salary or something like that. All these things can be done at AMP. The joining the data between different tables, and all the sorting of the data, aggregation of the data, everything will take place at the AMP level.
So what exactly the first one does? The parser. The parser basically checks for the semantics and the syntax error, and then
Yes.
it finds the execution
Parsing
plan.
engine does not processing the data, as I told you. It will only check for the session enabling, and then parsing the query and optimize the plan. Optimization is nothing but, for example, you write a select star from table name without any primary index. right? So it has to decide whether it has a primary index on the table or it has to scan the entire table, right? So based on your query, it will decide the best plan to the AMP. So it will guide the AMP basically how the data should be fetched, because the AMPs directly cannot decide on what data should be pulled in. So the parsing engine, who is the driver, actually send the instructions to the AMP. So basically to work out like this. Okay, I have this hash value based on this hashing algorithm. All these things will work in Teradata. So all the AMP operation will be done at hashing algorithm. So hashing algorithm is nothing but for each row in a database, it has a different hash value, hash hash row ID, whatever you can say. So for the corresponding hash row ID, for example, if you give where condition in the select clause, it will check for the corresponding hash value in the AMP. So it will be only one or two AMP operation. It won't need to scan the entire table because you have already a filter on the your condition where some employee ID is equal to 1234, right? Something like that. So basically, your query with all the filters and the joining conditions, uh, and the best explain plan can be given by the parsing engine. Based on the instruction, the AMP will actually work out all the stuff and get back to the data along with the BINET. I mean, with the help of BINET, because BINET is just a communication mechanism, point-to-point communication. So once the AMP is done with the data retrieval, it will go back to the parsing engine and send the data to the client, right?
So the data is spread across multiple disk storage, right? So that's what each AMP is corresponds to, right?
Yes, exactly.
Okay. So even though it's coming from, let's say if you do a select count star from a table, the entire set of data on that table has been split across multiple storage. So when we issue a command at the select star, so it gets
Yes.
parsed the very first one, and then it goes to all different data storage and gets executed in every single storage and returns the result, right?
Yeah, because the data is not only stored in one single AMP, it can be across multiple AMPs, right? So it has to
So,
count all the AMPs and it will work in parallel operation, so the data retrieval will be faster.
so one AMP can have only one disk storage, is that right?
Yes,
Okay.
corresponding storage will be one.
Okay. But everything sits on one server, right? All the
Yeah,
entire.
this is called a node. Complete node is called one server here. So here if you see a complete outline program about Teradata, so here you see PE, BINET and AMP, and each AMP corresponding to one virtual disk, and
Mhm.
here it is connected to LAN network, and there are two types of system. One is channel attached and one is LAN attached. Channel attached is nothing but which is mainframes, so that is different that we normally work on the LAN connections like in real time when you use Teradata. It is mostly LAN. Teradata mainframes is different. Like when you're using the mainframes to channel test system, you can actually use this channel based system for Teradata. So what we are talking about here, LAN, the LAN local access network to the Teradata gateway to the corresponding systems. I mean the client or whatever. So this is completely called a node. Node is nothing but a single system. And the best advantage of Teradata is whenever we want to increase the size of the database. Earlier days what happened, we have to shut down the database and take the hard backup, and you have to shut down for some time and again configure the new one, increase the space, and a lot of stuff needs to be done, right? So Teradata actually came up with a new concept to cross all these hassles. So basically, to have like a parallel database extension is a concept. Here PDE is just which will act as a connection between two servers basically. So by using this along with the binary driver, we can actually configure multiple Teradata systems parallelly. So without disturbing the existing one, and we can increase the space on the fly without any much what to say burden on the DBS and what the stuff. So that is the biggest advantage of Teradata. So we never know, right? Whenever our business grows, obviously we need Teradata database size to be increased, and without much overload on the DBS and existing systems. So that is what I mean. The Teradata came up with the concept BINET and parallel database extensions. So we can connect n number of nodes in parallel. so that the capacity will be increased automatically. So the only disadvantage of Teradata is nothing but it's very costly. So each Teradata terabyte space is actually in say 5 billion, something like this. So that is the only challenge in Teradata. So it's pretty costly compared to other database tools available in the market. But still, MNCs like Walmart, Anthem, UBS, there are different banking sectors, and a lot of MNCs like insurance sectors still using Teradata because they have the huge data to maintain. So whenever you have a requirement for huge data, they will go for Teradata compared to other databases. Okay. So any other questions here in the architecture, guys? Ritu and Aden. Aden, you're able to hear us?
Yeah, I'm saying like a parallel database extension is used
Yeah.
only to connect multiple nodes.
Multiple nodes. Yeah.
If we want to connect, like if one node then we will go for parallel database extension, or if we are using multiple nodes, then we'll go for.
Yeah. I mean, whenever you want to, the parallel database extension is like a inbuilt thing for existing server. Actually, with coming with Teradata, it's like a provision to add another node, right? So, like a hardware kind of stuff, not really data software. It's like a hardware connecting along with the software drivers for that. So, whenever you wanted to increase that, there's a provision to have that along with the BiNet cable. So, we can actually connect multiple nodes in parallel,
Okay, okay,
right?
okay.
So this is about architecture. We are actually discussing at the very high level. So maybe we can talk about more about the components, how the data is being processed based on the hashing algorithm. So that is more interesting because once you understand the fundamentals, because Teradata is a very good concept at architecture. So if you're strong at the fundamentals, you'll be able to tune your queries in a better way because everything will be roaming around all the primary index and the data distribution in Teradata. Okay. So we'll talk about that in detail, like once we start the session, the actual sessions. This is a demo, right? I'm just giving an overview. And coming to the course content, what exactly we cover as part of online training, right? So I'll just walk through the course content here. So I have divided this into multiple sessions. For each session is 2 hours, like that. I mean, we can have 2 hour session on a daily basis or an alternative basis based on your timings. Okay, so there are only around 8 sessions along completes 20 hours actually, including one session is for 4 hours. So basically, we can cover all this in 20 hours, like at 20 uh, hour sessions. So we can divide this session into 10 sessions. Hardly we can divide into 2 hour session for each thing. So we'll talk about Teradata, what is Teradata, logical architecture, parsing in all the components in the Teradata system. That is in the first session. And the second one is disk management, spool space, temp space, and type of logs, fallback mechanism, permanent journals, and all the space management data protection. So we'll talk about the second session as this. And the third one coming to this one, the data distribution based on your primary index, row hash values, primary keys, and secondary index in Teradata. And what is hash map and hash bucket. These are very important concepts in Teradata, the data distribution, because your entire database performance depends on these concepts. Because even everyone can write a query, select query, right? It's not a problem. But the only thing is how efficiently you can write a query, that is important, because some of the existing projects in Teradata you may get an opportunity to tune the queries, right? So in order to tune a query, a SQL query, okay, basically you have to know the fundamentals pretty well in Teradata. Otherwise, we cannot. I mean, we don't know where exactly we have to use the primary index and secondary index. Sometimes secondary index will be the better choice than the primary index. So until unless you understand the concept of the indexing in Teradata, because everything will be roaming around your primary index, secondary partition, primary index, all this stuff for your data distribution. So only thing is until unless you understand those concepts, you will not be able to guide your query in a better way. So that will run out, that will actually lead to the spool out error. Spool out is nothing but you're running out of your space for your query. So you will have some space allocated to your user ID. So when you're running a bad query or bad joins, right? So you will be running out of spool space errors. So we have to overcome this. In the real time, what happens is the spool space errors are the most common things, and along with your performance, issues. Okay, we'll talk about this indexing in the third session. And the fourth one is the other indexes, which are default indexes in Teradata, which cannot be controlled by the users, like hash index, join index. We'll talk about those. Okay, and explain plan. This is very important. So, what is an explain plan and how we read actually the explain plan? Okay. So session 5 is like the sequel, basically the joins and how to collect the stats, what are the type of joins in Teradata, basically all the SQL kind of stuff. And here the extension of the SQL, like data types, functions, format functions, all the functions, and then finally utilities. So Teradata comes with special utilities called fast load, mload, fast export. So these are different type of utilities for different purposes. So we have to demonstrate each utility along with an example, so that you can actually use them in real time. So BTEC is a common utility in Teradata, which is 70% of your work in real time will be done by using the BTEC scripts. BTEC is nothing but basic Teradata query, or they say batch Teradata query. Okay. And finally, the best practices, like what is the coding standards. So what is the best way of coding Teradata SQL or BTEC scripts, and what is the ways of improvement of your queries, the tuning of the queries, and along with the real-time scenarios, like because how we code in real-time projects on Teradata mostly. So this is about high-level course content. So any questions here?
Yeah, there are some classes for 3 hours and 4 hours. I don't think I can.
No, this is actually can be split into 2 sessions basically. Even though we write it as session 7, so we'll have 2-hour session, not more than that. We cannot have 4 hours, so we'll have 2 hours only. We'll be splitting these two into multiple sessions.
Okay.
Whenever it's exceeding more than 2 hours. Okay.
Okay.
It comes in around approximately 20 hours course, online course, and we'll be providing you the software. The software is like we need a server, VMware player and Teradata server. The server can be downloaded from Teradata website itself. So I can give you the instructions how to download and what is the ways of installing this, because and of course you need a latest processor in your laptop, like i3 or i5 or i7, because otherwise it won't support the VMware Play, the virtualization concept. So okay, so I hope you have the latest processors in your laptop, at least i3. Okay.
Okay.
So Teradata SQL Assistant is the one where we can actually write your queries, like it's like a Toad for Oracle. So it's a SQL Assistant for Teradata. So we have to install this one as a client, and the server is actually, I'm just loading it. This is through virtual machine. We can actually play it. It's like a simple plug and play kind of stuff. No need to no difficulty in installing Teradata. Actually, it is very simple and powerful as well. So this is the Teradata server. What I'm showing here is a Teradata server. So let me just show you. So this is a server. You can see all your, you can write all your Teradata scripts and all here, and only the queries on the Teradata SQL Assistant. So we can connect the SQL Assistant with the VMware player, so that actually you can write all your queries here directly into the SQL Assistant. Okay. So let me just show a simple query. For example, I'll just show you what is an explain plan basically. So I'm just using select from student. Let me just write this query and execute it. So here I got around let me say 5 rows of this table, right? Select from students. So for example, if I do explain plan F6 for this. So you write simply select star from table name. So what it is saying, explain plan. We do an all AMP retrieval step from TDDF student by way of all row scan with no residual conditions. That means what we are doing here is we are doing all AMP operation because there is no where condition in your query, because all your data we are scanning the entire tables. So all AMPs will work in this case. And if you see the definition of this table to make sure that what is a primary index on this table to query. So this is the definition of the table. If you say so, show select star from table name, it will give you the definition of the create statement. So here my primary index is on the name field and the secondary index is on the subject one. So if I say select star from students, for example, where name is equal to, for example, Ria. Let's say the second one, right? So if I execute this explain plan, right? So what is the difference now? Let me just execute it. So if I just execute, I got one row. I have to do the explain plan for this. Let me get F6. So if you compare the difference between the initial and now, if you see, first we do a single AMP retrieval step from student by way of primary index TDTF student name is equal to Ria with no residual conditions, which is built locally on the time. That means it is a primary index way of retrieval with a single AMP. Whenever you are using the primary index, it will be always a single AMP operation, so that the data will be much faster, right? When you are, instead of working on the multiple AMPs, if you are working on a single AMP, it will be much faster, obviously, right? So that is what the explain plan will tell you based on your query. It doesn't matter how big your query, it will still give you an explain plan for your query. It will tell you where are the possible way of detecting the errors and the loopholes in your query.
Primary index is just like a primary key?
Uh, that is what actually there's a difference between primary key and primary index. So I'll tell you actually. Primary index is basically in Teradata is purely for distribution purpose, and here the primary index can accept null values and duplicates. But whereas in primary key we cannot do both, right? Like we cannot have null values or duplicates.
That's right. So if you have more than one record, let's say there are 10 records where name is equal to Ria, so it could be stored in different AMP, right? So in that case, it won't be like single AMP. You see what I mean?
Can you come again? Sorry.
Okay, let's say we have multiple records where name is equal to Ria.
Okay.
And if you execute the same command, select star from student where name is equal to Ria, we might not get the single AMP retrieval step, right? It could even be multiple AMP, right?
No. When it is a primary index, it's definitely a single AMP.
So that means all students whose name is Ria get stored in just in one AMP. It won't go to multiple AMPs.
Yeah, when you define when you define a primary index on a name field, it will be a single AMP only.
So when you say AMP is nothing but a disk storage, right? It refers to actual disk storage, right?
Not a typically disk storage, it will do more than that, right? So as I told you, all this sorting, performing the data operations within AMP itself. So all your searching of the hashing values based on your indexing field, okay? So the corresponding hashing value, it will just go for, because the hash value will be same, right? Obviously whenever the name is same, the hashing algorithm, it will define the same value, which will ideally located in the single AMP. Right? So whenever you define a primary index on a table on retrieval, so it will be always a single AMP operation. And whenever you define a secondary index, it will be always 2 AMP operation. So we'll talk about the detail, not a problem. Once we go into the detail, we'll understand better on this indexing concept. It will be very interesting, I mean, while you practice the SQL. So with the data, you play with the data, you'll come to know the many facts with respect to the, the sharing of the data and the distribution of the data.
So does your course content have anything special for DBAs, Teradata DBAs?
No, this is typically, I mean, this will be, any DBA actually should start with development, to be frank. So until unless you understand the architecture and the development aspects, we cannot go to the next level. So this is typically a development layer wherein you develop Teradata scripts, all your BTech 4, SQL, and your application development with Teradata will be completed with this course. DBA is, something beyond that, to configure the number of AMPs for a software, I mean, for the database and all. That is much bigger than this, and we are not working on that side, DBA side. But actually, we are actually going through some of the DBS concepts as well, like the performance and all, and query distribution, AMPs, algorithms. We don't need to really look into that detail, but during our course content, we go for some DBS aspects as well, so that will be easy for you to start with DBS. So my recommendation is, like, we have to get this done before going for a DBA course. Then only you can understand better way of working on Teradata, because there are certification is available in 14 version now. Currently we have around 5 or 6 exams. The first one is Teradata basics, and then SQL, and the third one is physical implementation, and the fourth one comes to DBA stuff. Okay, so they give in the based on that order as well. So until unless you come across those three, we cannot go for the DBA certification. So
So
as simple as that. Yeah.
okay, so this course basically, after attending this course, I can go for first 3 certifications, right?
Yes, exactly.
Okay.
Teradata 14 you can go for that. Teradata basics is plainly theoretical, and the SQL is nothing but all the SQL programming, and third is physical implementation. That is more similar to SQL only.
I see.
So that is about the course content.